Okay, so today we're looking at the slope of a line. Slope of a line is how steep a line is. So we're looking at the steepness. So some lines don't have a lot of slope, some have more slope, some have a lot of slope. And then what about when? And so the slope of other lines going in the other direction are different. And so we're going to compare those slopes and explore this today. So it's a ratio, slopes are a ratio, ratios can be fractions of the vertical change, which is our rise, and our horizontal change, which is our run. So we usually start with slope equals rise over run. Now for slope, we usually use the letter M. And we then have the change of our y values, because our y values are the vertical change, and we have delta x, which is our x values. So this little triangle means delta, or is called delta, it's a Greek letter. And what that delta means is change. So change in y values over the change in the x values. The sign of the slope, now the sign of the slope, which is plus or minus, indicates the directions of the line. It doesn't tell us the size. So looking at line A, what we have to do is find two places where the line touches the corner of the grid so we can just count the squares. So on here then, we will count our rise. We will go up from one point to the other. We'll go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we go up from here 10 squares. And then what about over? So going over to this point here, we go over 1, 2, 3, 4, 5 squares. So we can say our slope, M, equals rise over run. The more you write this down, the more you remember it. And our rise is 10, and our run is 5. So that's the fraction. Now, if we put that in lowest terms, that would be 2 over 1, and that in lowest terms is 2. So sometimes what we're going to see is that our slope can be fractions, and then we should reduce them, and sometimes they'll actually even reduce to integers, and then we should write the integer. Okay? Let's find the slope of line. Now, there's other slopes that we could have picked as well. We could have gone the other direction. So we could have counted our run this way, 1, 2, 3, 4, 5. And then counted our rise this way, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so we'd still get a rise of 10, and we'd still get a run of 5. And so we would make a little triangle in this other direction. So you can make your triangle any way you want, okay? But you got to be able to count your rise and your run. So it's just a triangle to help you count. So this is your run, and this is your rise. All right. Now you notice that for our lines, we always read our lines from the left side to the right side. So from the left to the right, just like we read a book. And that's why we have to measure our run in this direction and then a rise in that direction, or up and then over, your choice. That's the direction we have to count. Now for line B, I'm going to find 2 points on the corner of a grid, say right here and right here. And so now what I'm going to do is count my run. I'll go this direction, 1, 2, 3. And so M equals rise over run. The more you write it, the more you remember it. Run, which equals the run of 3. And now I'm going to go down, 1, 2, 3, 4, 5, 6, 7, 9. So if I'm going down 9, I'm not going up, am I? So if you're going down, how would you reflect that numerically? Well, -9. So my rise is -9. On my triangle, I get -9. Lowest terms then, divide by 3. and I get -3. Okay. So which line's steeper, line A or line B? Well, remember it's B because the negative sign tells us the direction. It doesn't tell us the size. Okay, so it just tells us the direction of the line. Okay, what about line C then? So go ahead, find two spots right here and right here, make your triangle. So here's my run, count the squares, 1, 2, 3, 4, 5, 6. So my run is 6. And then my rise, I go up, 1, 2, 3, 4. And so for line C, it's 4 over 6, rise over run. Lowest terms, 2/3. And it's actually quite common to get a fractional slope. Okay. So just to now, you should notice you can find other places here on the grid. You could go and use this line and get 2/3 or up 2 over 3 or even backwards, but you'd still then get two negatives, which would be a positive. So this would be -2 and -3 if you counted backwards, going down and left. And so -2/3, -2 over -3 still equals +2/3. All right. Positive slopes, they go up from the left to the right, and negative slopes go down from the left to the right. Okay. So up versus down. Okay, so go ahead quickly, try and find the slopes of these ones. D and E are going to be special, but you should be able to do these three quite easily. Go for it. Okay, hopefully you found the slopes. So for line A, I'm going to pick this point here and this point here, and it's 3 and 3. So my slope is 3 and 3, which equals 1 over 1, which equals 1. Now you could have picked any points. You could have picked a point to give you 1 and 1. You could have gone 2 and 2. You could have gone 3 and 3. You could have gone 4 and 4. There's lots of different areas on this line. You could have used the slope and still gotten the same answer. Line B. So line B, where's line B? Right here. So I'm going to choose this dot is right on the corner and this one here. So I'm going over 1, 2, 3, 4, and I'm going up 1, 1. So my slope is 1/4. Line C right here. Geez, this one's a tougher one. Right here for sure, and right here for sure. So I'm going to go in this direction, 1, 2, and that will be the bottom. And then I'm going to go down. So -1, -2, -3, -4, -5, -6, -7. -7. So that actually is my slope then. My slope is simply -7 over 2. And why is it negative? Because it is going down. So if you have to count down, that means you have a negative value. Okay. So think about this, right? If you start at this point, if you count up, that is positive. If you count down, that is negative. Now, if you're reading the graph properly, if you count in this direction, it is a positive x values. But if you're counting in the left direction, that would be negative x values. And you've seen that before with our x and our y's. These are all positive directions, these are negative directions, these are positives, and these are negatives. So the grid actually even tells you how to count and whether you're counting positive or negative. Now, line D. 2 points right there. My rise equals 0, and my run equals 1. Go to your calculator, see what you get, and you get 0. Okay? Then for E is right here, 2 points on the line, so my rise now equals 1, and my run equals 0. And so what happens when that is in the opposite direction? 1 divided by 0 cannot divide by 0. Duh. So this equals null set. Okay. Or you can say that it is undefined. And undefined is probably the more common one. Or you can say D and E does not exist. This one is more rare. You don't see that too often. Most teachers will use a null set or undefined. So why is the slope so important to know? Because we can graph from it. If you plot this point, -4/3, we can use the slope to count other lines. So -4 would be 1, 2, 3, 4, and 3 is 1, 2, 3. So there's the point 4/3. Okay, I'm going to make it big so you can see. So now what you're going to do is you're going to count. So I'm just going to go and I'm just going to count my slope, -2, 5. So if the slope, m equals -2/5, you have to assign your sign to the top or the bottom. I like at the top. What does that mean? Well, -2 tells me to count down. The negative sign is saying count down 2 spots. And since 5 is positive, I count 5 right, or right 5. So looking at my counting now on the grid, I can count down 1, 2, 1, 2, 3, 4, 5. 5 spots. So there's the next point on the line. Then I can erase my counting lines. I'll do it again. Count down 2, 1, 2, count right 5, 3, 4, 5. That's another point on my grid. Then I can do the same thing. Count down 2, 1, 2, 1, 2, 3, 4. Oh, I'm done. So those are 3 points on my line. But notice, remember how I said I could also write my negative sign down below. And so I'd be counting the opposite direction. The +2 plus 2 tells me to count up. Positives count up, so you count up 2. -5 tells me to count left 5. So from my original point, I will count up 2, 1, 2, right 5, 1, 2, 3, 4, 5. And there is the next spot on my line. So now I can go and I can make a line. So I'll grab my line tool and voila, I get a nice line using a ruler. Make sure lines are long, lines are long. There we go. Okay, and so that's a line through all those points, using your slope to count. Remember, when you're counting, you're going up, it's for positive values on the rise, negative values on your rise. Going to the right, it's positive runs, and to the left, it's negative runs. All right, so you can count your slope in both directions. Okay, you must count the slope in both directions. Very important to know and to be able to do. All right, there you go. Continuing on. So in a real world situation, okay, so in a real situation like the slope of pipes in the roof, right? For plumbing, slope of a road, in a real situation, the slope is always positive. Because there's no real left or right, because if you turn around, your left is your right is your left. So slope is always positive for real situations. So if we look at this sign over here, if you're trying to find the slope of the road, you will not actually measure the road. It's really weird. What you're going to measure is the rise over the run. So you're going to measure the rise of the road, and you're going to measure the run of the road. And so using a ruler, if you had one, you would measure this here to 10 millimeters. That is your rise. And you would measure this here, your run, and you would see that would be 20 millimeters. And so your slope of 10 over 20 becomes a slope of 1/2. Okay. And so in a real world situation, even though that's right, you wouldn't worry about positive or negative lines, slopes. It's always positive. Any questions? So often we're asked to find the slope of 2 points. So here we have 2 points. To find the slope, you can do a couple different ways. You could graph, and you're going to do that in your homework. You could graph the points, and then you can make your triangle, and you could find your run, you could find your rise. Oops. So, however, you can also use this equation to help you find your rise and your run. Your rise is the change in your y point values. The run is the change in your x point values. So let's go ahead and use those equations. What's important to see is that this is y2, x2. That is from one of the points. They line up vertically, the points. The other value is y1, x1. So those the other point lines up vertically. So m equals, which one do you want to be y2, x2? 3 over 4? Or 2 and 6? Tell us what to do, Emerson. Sure, it does not matter. So this, remember, is my x, that's my y. So I write down 4 and 3. And it's always a subtraction, always, always, always. And then what's my x and my y for the other point? 2 and 6. So 6 is on top, it's the y value, 2 is on the bottom. Okay, what's my answer now? What's 4 minus 6? -2. 3 minus 2 is 1. Simplify that. What's the answer? -2. Okay, let's do the next one. Now, I'll decide, I'm just going to put the first one on the top, the first point. So I have 17 and 3. You go ahead, set up the next part. Go. So you should get 19 and -5. Notice the double signs. Please be careful. It's the only thing you can screw up for this part. Okay? You should have 2 subtraction or minus and a negative sign. So what does the top equal? Good. What does the bottom equal? Well, that turns into 3 plus 5. 8. Okay, simplify now. -2 over 8. Trevor? Good job. Okay. Okay, so next one, which point do you want to put first? Tyson. Okay, so there's your x and your y. So it'll be -5 on top, -3 on the bottom. And we're always subtracting them. Okay, write down the next point. Go for it. So we get minus -9 and minus -6. So really that works out to be -5 plus 9 over -3 plus 6. Now if you don't want to do that simplification, that's okay. But you should get 4 over 3. Hands up if you got that. Good. Leave it as an improper fraction. Rarely ever enough anymore do you go to a mixed fraction. It's always going to be left as improper. Go ahead, do the next one yourselves. Do the next 3 yourselves. Go for it. How many people got 12 for that one? Good. Did anyone put, so what I did is I put this second point at the front. Did anyone else do that? Oh, still, sorry, thanks. Okay, so I had positive 12. And so I put the negative 18 and negative 5 at the top, at the front. Did anyone else do that? No? Notice that we got the same answer? So it doesn't matter which point goes first. What matters is that the point lines up vertically. And so the other point here has to line up vertically in the other location. Okay? Go. Anyone getting some weird answers for the next two? You probably will. Go ahead and finish them. Okay, so the last two are a little tricky, weren't they? One would be 0, and the other one is null set or undefined. Okay, it's undefined. Any questions? All right, so what I want you, we're going to go and do parallel and perpendicular lines later, but in the meantime, we have these two worksheets. So what we're doing with these two worksheets, if you find them, and we'll do the first one together. Okay. So, first thing you're going to do is says draw a line using those 2 points. So we have 1 and 2, and then we have 4 and 4. And so now you can make a line with a ruler. Now, if you don't have a ruler, take a piece of paper, fold it twice, and you do have a ruler. So any paper, if you fold it twice, it's going to be a nice, thick, straight line. Okay. So when you say you don't have a ruler, you're lying to me. You always have a ruler. Now what you have to do is find your slope, so you can now find your rise and your run. So my rise is 2, and my run is 3, so my slope equals 2 over 3. So where I have the slope, 2/3, I'm going to put the letter E. And you can see I did that down below, and you get your word phrase. Okay. Any questions on how to do this worksheet? Why are you talking? Yes. Draw your lines off the row. This one here is going to be somewhat similar. You're going to find your slope, except once you find your slope for the second worksheet, then you cross off the letters, the remaining letters, make your word phrase. Okay? For these ones down here, you have to do your slope equation. Okay, so you're doing your slope equation. Any questions? Go. Shouldn't take you too long, then we'll move forward.